motion, numericals based on equations of motion. The first numerical problem that we are taking up, a trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What will be its velocity 3 seconds after the start? So here a trolley is coming down an inclined plane. Okay, so at the top of the inclined plane it starts from rest, so its velocity there is 0 at the top. So that's why we will take initial velocity of the trolley to be 0. So here whenever we solve such numerical problems, we always have to first of all write the given quantities, all the given quantities. Like initial velocity, as I told you just now, it will be 0. The acceleration, it is given in the question, 2 centimeter per second square. Then the time interval that has been given is 3 seconds, because we have to find the velocity after 3 seconds. And the final velocity, which is unknown, and we have to determine what will be the velocity after 3 seconds. So final velocity has to be determined. That's why it is unknown here. Now we have to check which equation of motion is applicable for all these quantities. We have written all the quantities with their symbols so that it becomes easier for us to recognize or to decide which equation of motion out of the three must be used or which one is applicable. So obviously u, v, a and t are given. So the first equation of motion, v is equal to u plus at, will be applicable here. So in this first equation of motion, v is equal to u plus at, we put all the quantities. V is unknown, so we will put v only here. U is 0, as I have explained just now. A is given to be 2 centimeter per second square. It is given in the question. So A is 2 centimeter per second square into T. T is 3 seconds. So we put the value 3 seconds. Now we know that 2 into 3 is obviously 6. So it will be the numerical value of the product will be 6. And then units, for units, centimeter upon second square, when it is multiplied by second, so centimeter upon second square into second, so 1 second gets cancelled here. So what remains is centimeter per second. So the result is 6 centimeter per second. That means the velocity after 3 seconds from the start is 6 centimeter per second, which is the result of this question. The next problem that we are going to take up is a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? So again, we follow the same procedure. For solution, we first write all the given quantities. So we have been given initial velocity again 0 meter per second, because obviously it will start moving from rest, so initial velocity 0. Acceleration has been given in the question 4 meter per second square. So we have taken acceleration a is equal to 4 meter per second square, and the time interval given is 10 seconds. So we have to find the distance it will cover in 10 seconds after the start. So time is 10 seconds. And the unknown quantity here is distance covered, which has to be determined. So distance covered is represented by small s. We have to find its value. Now we will check which equation of motion can we apply when we are given S, U and T. S, U, A and T. So obviously we can easily use the second equation of motion. S is equal to ut plus half at square. That is what we are going to do. Since S is unknown, we will put its value as S only. Now we will substitute the value of U, T and A from the question itself. So we substitute the values like this. here u is 0, so we have put 0 meter per second, and t is u into t, so t is 10 seconds, that's why we put 10 seconds, plus the second term half a is 4 meter per second square, so we put 4 meter per second square into t square, the square of time, that is 10 second whole square. All right, so we have 10 second square. On solving it, 0 into 10 is 0 into 10 becomes 0 only. Whatever you multiply anything by 0, it becomes 0. So the first term becomes 0 in itself, plus the second term. In the second term, half as it is, half has been written as it is, 4 meter per second square into 10 second square. 10 square of 10 is 100. 10 का square होता है 100. So the 10 second square becomes 100 second square. That's what we have written here, 100. Now second square in this term and second square in denominator get cancelled out and only meter remains. So that's why in the result here we have taken 4 into square of 10 is 100, so 4 into 100, and overall the unit that is left is meter. So 400 meters. So half, now half of 400 meters. Here we have half into 400, right? Half into 400 is nothing but 200. You can easily find out. So that's what remains. We will have 200 meters. So we see that the distance traveled by this racing car in 10 seconds after the start is 200 meters, which is our answer for this question. The third question that we take up here, a train is traveling at a speed of 90 kilometers per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Now, this question is slightly different because in this question, our object does not start moving from rest, but it comes to rest after some time. So here, as you can see, the acceleration has been given as negative acceleration, minus 0.5 meter per second square. So negative acceleration is given. That means retardation. I have explained you about retardation in the previous classes. So here we have to take acceleration as negative. Again, we follow the same steps for solution. We first write the given quantities. So we have been given initial velocity as 90 km per hour given in the question. This time initial velocity is not 0 because here final velocity is going to be 0. So initial velocity is given 90 km per hour and we have to convert it into SI unit. So that is meter per second because acceleration is given in SI unit. So we must convert velocity also in SI unit. All quantities should be in the same unit system, and it is better if we keep it in SI unit system so that no mistakes will be there. So it is compulsory if acceleration or other quantities are in SI unit system, then you must convert the velocity also in SI unit system. So all in all, in a given question, in a given numerical problem, all the quantities involved should be in their SI unit system before you start solving. So here we are converting kilometer per hour into meter per second. 90 kilometer can be written, 1 kilometer is 1000 meters. So 90 kilometer is 90 into 1000 meter upon per hour means upon hour or per hour means upon 1 hour. And 1 hour can be written as 60 into 60 seconds. So all in all, what we have here is 90,000 meters upon 3600. 60 into 60 is 3600. You all know that. So 3600 seconds meter per second में convert कर रहे हैं हम इसको, ठीक है? So 2 zeros get cancelled out easily. Okay. Now 9 we divided with 9. 9 4 times and this is 100 times. You all know division, right? This is very simple. So 400 upon 4 is 25. So that means when we convert 90 km per hour into meter per second, it is 25 meter per second. So we have converted the velocity into its SI unit. Now our numerical can be solved. Then the next given quantity is acceleration. In the question, it has been given minus 0.5 meter per second square. So we have to take the negative sign also. Then final velocity is 0 because train is brought to rest. So we have to take the final velocity as 0. Keep this in mind. Please read the question carefully. Now we can easily see that because u, v and a, the three quantities involved are u, v and a. So we must use the third equation of motion. V square minus u square is equal to 2as. So we put all the values except for what we have to find. What we have to find is the distance s. So except for that, we put all the values. So again, if we solve this equation, we further solve this. We get s is equal to v square minus u square upon 2a. We put all the values. V means 0. Square of 0 is 0 only. U square means 20. We will take only SI unit value here. So 25 meter per second whole square upon v square minus u square upon 2 into a. A is minus 0.5 meter per second square. So minus 0.5 meter per second square. We have just substituted all the values in the third equation of motion. Now when we solve, what we get? You see, 25 square. Square of 25 is 625 and 0 minus 625 means minus 625. So here we have taken 25 square और 0 माइनस हो रहा है इसलिए there will be a negative sign. 25 का square होता है 625. So we have just taken that value here. So minus 6 because 0 minus 625 will be minus 625 और इसका यूनिट का भी स्क्वायर होगा, that's a meter square upon second divided by 2 into 0.5. 2 into 0.5 is 1 only. We all know 2 into half is 1 and negative sign is already there. So we have to put that negative sign also. So here numerator में भी negative है और denominator में भी negative है. The two negative signs will get cancelled out. The negative in numerator and denominator will get cancelled out. And 625 upon 1 is 625. Second square get cancelled out. Meter cancels 1 meter and only 1 meter term remains. So overall the value is 625 upon 1, that is 625, and the unit is meter because it is the distance. So that means the distance covered after by this train before it comes to a stop, it is 625 meter, which is the answer to the given question. 625 meters after applying the brakes. Thank you. Like, share and subscribe to the practical side for more interesting and informative videos.